So this is the second video in the series in which we want to create a snapshot from a disk in a customer subscription, transfer that snapshot over to our ISV side subscription and mount it to our inspection virtual machine. This time the difference will be that the virtual machine's disk will be encrypted with a customer managed key, or to make it more complex, we want to create a virtual machine with not only a customer managed, but with both platform managed and customer managed keys, because I guess like that sounds more complex, so to say. So here I'm currently creating the virtual machine on the customer side of the house. I'm creating this currently in a special region in Azure, in which the feature is enabled. Now I see I actually need a disk encryption set first, so let's do that. Let's create a disk encryption set over here. Disk encryption set. So a disk encryption set basically is a virtual machine's way to get access to a customer managed key. So our disk encryption set DEK should be living in this canary region here in US East 2 EUAP. We want to support double encryption even with platform managed and customer managed keys. The key vault which we want to use must be in the same tenant and in the same region, which is Azure Geuer-KV. We want to create a new key over here, so K1. It should be like whatever, that sounds better than the other. Enabled, no expiration, no nothing. It should not be exportable. That sounds like a good one. And let's just create and review this. So a disk encryption set effectively is like pointing to a specific key in key vault, right? So to also show what's going on, I didn't go for the kind of key vault specific authentication mechanisms, but instead I said like I actually want the very same Azure AD authorization and authentication mechanism which is kind of in the platform, right? So let's just have a look at the key vault for a minute. So here's our key vault, and you can see in the access policies I disabled the vault specific access policies and instead went for the Azure role-based access control model. And I flipped this feature for disk encryption for volume encryption because that's actually what we need here. In access control, I did not yet do anything special. So this is basically like I didn't grant myself privileges or something like that. And nothing yet happened down here. So let's wait. Let's actually see what happens with this deployment here. So let's go to the deployment of the disk encryption set. It's gone. It went through. So let's go to the disk encryption set itself. So we see it is platform managed and customer managed keys. Currently no virtual machine is using the disk encryption set. Here we can see it is pointing to the CH-Geuer key vault, to a specific key in a specific version. So up until now, so the disk encryption set itself has a managed identity, a hidden managed identity under the hood. And right now, as we could see, that disk encryption set is not yet authorized to tap into the key vault. So one thing which I could do is when I click this button, it gives my disk encryption set permissions on the very specific key vault. But let's actually do this at the subscription, it's a resource group level. So here we should be able to grant a role assignment. So, no, we want to add a role assignment. So the role assignment which we want to add is for, let's search for key vault crypto service encryption user. This is the one which we want. And we want to grant these privileges to, do we have this here? To a disk encryption set, to the DEK1. So you can see disk encryption set. I should have named this DES instead of DEK. Anyway, so now I grant this privilege. Let's do this role. This is basically work which the customer would have to do, right? So now our DEK shows up as an application which is authorized to do a key vault crypto service encryption user on all key vaults in the given resource group. So let's just validate that this is true. Let's so here's our disk encryption set and here's our key vault. So let's just go into the key vault and let's have a look at the access control over here into the role assignments. So we can see that this key vault inherited DEK permissions from the surrounding resource group. So this is how it trickles down. So if we now go to the disk encryption set and so now this warning kind of disappeared because suddenly it has access to the key. So now I can flip back to, well, let's go back to a previous step so that the portal reloads the customer encrypted. So let's go for platform encrypted using, why doesn't it show? Let's go to marketplace again. I'm not sure what I did here. Virtual machines. Create a virtual machine as a customer. We want to be in this particular region down here. Customer VM encrypted. Geuer and use a key which is stored in Azure, like that one. Let's pick this one, and now we see our disk encryption set. And that pretty much should be all we need as a customer. So I will just pause the video for a minute until this validation failed. What's failing here? Running final validation. Actually, nothing's failing. So let's just spin up this encrypted VM, or that VM with an encrypted operating system disk with a customer managed key in that customer resource group. So my earlier deployment failed because I forgot one thing. I got an error that the deployment failed. Let's just go to the failed deployment. So the error message which I got was that in my key vault, I forgot to turn on purge protection. So purge protection must be enabled. This is effectively so that no one can, while all the VMs are running, basically delete and purge away an underlying key vault which is necessary, a key for which is necessary for the underlying VMs to operate. So I just basically flipped on that feature, the purge protection, and redeployed the machine. So let's just have a quick look into the key vault, into the properties, I guess. So here I turned on purge protection, and once this is enabled, it cannot be disabled. I forgot this initially. And now we should be having in that resource group, we should be having a virtual machine which is encrypted. So let's just have a look at the disk, at the encryption properties. So this is encrypted with both a platform and a customer managed key. User and the decryption key is fetched via the disk encryption set, which we had earlier. And it's currently attached to our encrypted VM. So when we look at the encrypted VM over here, we can see that the operating system disk is encrypted with platform and customer managed keys. So let's do the same thing as before. Let's quickly hop onto the machine and make sure we touch a file so we know that this is ours. So SSH over here. Yeah, sure. Touch Christian was here. Something like this, and then 22 08 15 15 53 dot text. Something along these lines. So here we have our file, which we will later be expecting to be available in the snapshot. And that's all there is to say for the customer side setup, so to say. So now we have a virtual machine and a disk. So how does this look like in practice? On the customer side, there is a virtual machine. The virtual machine has the OS disk attached, and the OS disk leverages a disk encryption set, and the identity of this disk encryption set is authorized to be a crypto key user of K1 inside the key vault, which lives in our resource group. What we now will be setting up is very similar to our previous thing. We will create a multi-tenanted app on the ISV side. We will create a service principal on the ISV side with a password to be able to manage our infra. We will create a representation of that service principal also at the customer side. And once we create the snapshot and we materialize this in a disk, the trick is we need to be able to read this key over here. Like, this key is the one which we need in order to mount and attach the disk to the scanner VM. We cannot use the disk encryption set over here, and we also cannot simply create a disk encryption set which reads the key from here, because Azure Key Vault expects a token to be issued by the customer tenant. So only the customer Azure Active Directory issues tokens which are accepted by the Key Vault over here. So we somehow need to do a trick that we can still kind of, in air quotes, read that key over the over the tenant boundary. And the way this happens is, in this preview feature, like this, the customer side disk encryption set has somehow an implicit managed identity. You might remember when I went into, where is the disk encryption set? Over here. It basically had, we didn't even see an identity over here. Like, it just had an implicit identity. Like, when I go to the Key Vault and I look into the access control, I can see that the DEK, the disk encryption set we created, has an authorization here. But that DEK user somehow is an application in my Azure AD where it's not really clear like where this comes from. In this preview feature, we can create a managed identity, an explicit one in our resource group at the ISV side. And we can attach this managed identity to our disk encryption set. This in itself is not yet helpful because this managed identity cannot read the key because the managed identity lives in the ISV tenant and it cannot go here. But what we can do is, once this service principal is installed in the customer tenant, we can use workload identity federation, which is basically we say, hey, dear managed identity, when you try to grab a key, use the token which has been issued for you to sign in to this service principal, and this service principal is then authorized to read that key. So this is kind of the nifty feature we wanna use over here. So the disk encryption set is tied to a managed identity. The managed identity uses workload identity federation to sign into this service principal, and we authorize that service principal to read the key. And this enables us to kind of bind the disk once we copy it over. In the previous demo, I used my Geuer-Pollmann Azure Active Directory tenant to demonstrate how it works in Azure. The feature which I need now is not yet allow listed in this tenant. So I need to kind of mimic my ISV operations in a different Azure Active Directory tenant and in a different subscription. So the one where I am now working is a Microsoft internal tenant called cross-tenant CMK for ISV demo. So inside this one, we will be using a different subscription now and a different resource group for our tests, basically. So here we have a cross-tenant demo resource group. So let me just create a new resource group over here. So the resource group is Geuer demo. And the location for that resource group is our Canary region. And I owner, let's give it just my email address so people know who's playing with it. So let's create that resource group. And so now we basically copy these values over into our script. So where are we playing? The resource group for our thing is Geuer demo. The resource group name on the customer side is customer CMK-encrypted. That's all great. So let's just run the very same scripts we did before. So a slightly different ISV tenant, the same customer environment basically. Now we are storing our service principal secret in a different file. Sign into our Azure AD tenant on the ISV side. So now I will be using this identity to kind of mimic the ISV. Great. So we're signed in now. And now we are creating our preview feature, multi-tenanted application for virus scanning. So let's create a multi-tenanted application, and once that multi-tenanted application exists, let's quickly have a look over here in Azure AD. So in Azure AD, in the app registrations, I should be seeing my application. Owned application, it's not yet there. There is always like this kind of 3, 4, 5 second eventual consistency delay until things become visible for me. But I can already have a look at the JSON which has been created here. So echo this one and pipe it into JQ. So there is already something in here. So again, it is a multi-tenanted application, so I can see this application in other tenants. Here is our application, right? Our preview feature application. We are going to remember a couple of values like the object ID and the app ID. We are going to create our service principal. So let's just use the same mechanism as in the previous demo where we now have our multi-tenanted application. This is here. We have our service principal. This is here. We have our resource group. This is here, right? Let's grab the ID and let's just print out all the different values. Okay, so here, multi-tenanted object ID, app ID, and the service principal object ID. These we have. Now let's make the service principal a contributor to our resource group on the ISV side. So just as a reminder, this guy should be able to manage this resource group. That's what's going on here. Now we call into Microsoft Graph to create a password for ourselves so we can easily sign in, because we are running on my laptop and can't use a managed identity for all of these things. So let's grab the secret and store it in a password file. So now in encrypted disk access we have our password. So with the customer managed key, the disk in the customer subscription is encrypted, and the disks, this is basically how it works. And let's skip over this. Now let's create a user assigned managed identity on the ISV side. So AZ identity create in our resource group. So once that happened, we have this managed identity, and let's make some bigger outline here because otherwise it's all hard to see. So now we have the managed identity, and let's grab the managed identities values and print them out. So our managed identity has a certain client ID and a principal ID. So if I go into the resource group here, Geuer demo, we now should be seeing our user assigned managed identity for Key Vault access in the customer tenant. And this is right now, this identity has nothing specific enabled. It's just exists there. Okay, cool. So now what we are going to do is we create a workload identity federation description. And let's just output this one here so you can see echo what's in the message here. So the name is Key Vault access. The issuer is our own Azure AD tenant. The subject is the user assigned managed identity. And we want to be able to sign in somehow. So where do we use this? We grab a token for graph. And now we create this link here. So we now create the link. Let's make this really big here. We now create the link, which, okay, that is shitty in terms of colors. Sorry for that. We now create the red link so that this user assigned managed identity can use actually this service principal here. The other one doesn't even exist yet. But it can basically use via the service principal actually really the managed application, right? So we now fire up this call, and so what happened here? Let's just have a look where we can see the setup of this. So let's go to our Azure Active Directory. Let's go into the app registrations to the application we created earlier. And in the certificates and secrets section, there is now a federated, so there are two values. This is a password which we have in our text file, so we can impersonate this service, we can use that service principal. Here is a federated credential which we just injected into the system. So let's just have a look at this. So we can see if the ISV tenant issues a token for this particular subject, it tries to, use this object ID to do something, to access a resource. This is the setup which we did in this graph call. So finally, let's just have a look at our service principals property. So let's just grab a access token for the service principal and print out some identities. So here 3D1 something is the issuer of our service principal. As mentioned earlier, you need to register this allow AAD auth for data access feature because we want proper Azure AD rather than shared access signatures and stuff. And now it's time to hop over to the client side and to register our multi-tenanted application in the customer tenant. So let's go ahead with this one. Let's sign in to the customer Azure AD tenant. Currently, I'm kind of using the same email address for both the publisher and the client, but the tenants under the hood are different, right? So now, when I have a look, I'm basically signed in to the Geuer work, which is my simulated customer. Here also the feature needs to be registered, and as you already saw before, the feature is registered, right? So we can use it both on the ISV and the customer side. Let's now create our service principal. So after this step, this one here is great as well. By the way, the key vault is already there. The encryption set is already there. The disk is already there. So these bits and pieces and our key K1. Okay, that's not our key K1 is also already there. So now we have the service principal. Let's remember these IDs as well. So here we have the IDs for the service principal. Now we need to grant ourselves permissions on a couple of things, on two things specifically. Like in the earlier demo, we need to become a disk snapshot contributor. But we also need to be a key vault crypto service encryption user, which gives us the permission to, read encryption keys. So let's do the same thing at the subscription level. So the disk snapshot contributor ID is this one. So we grant ourselves disk snapshot contributor permissions. And let's just, as a customer, have a look on what happens. So in the resource group, in the access control, there should now be a disk snapshot contributor. The Geuer-Pollmann DE was the one from the previous demo, and here we now have the preview one from the other Azure AD tenant. And we also need to do the same thing to become a key vault crypto service encryption user on the very same thing. So let's slap on this role assignment on our subscription as well. I did it at a full subscription level here. So let's refresh. And now here we can see that there are now two key vault crypto service encryption users. The disk encryption set from the same subscription is on the resource group, and our multi-tenanted application from the ISV side is a key vault crypto service encryption user on the complete subscription, which means on all key vaults in the subscription, which is a pretty wild permission, and you need to figure out how you want to strip this down. The tenant group thing I showed already earlier, so let's just skip these ones because we don't need them. And now we are ready to rock. So now we somehow let's just grab our, let's just sign in to the customer. I think we were signed into the customer side, but let's just do it again. What was the name of our VM? Our VM was called customer VM and encrypted. There's even a typo. It's good that I have a look. So our VM name is this one. So the VM resource ID is customer subscription, customer RG encrypted, customer VM encrypted. So let's grab the description of the VM. And let's just have for a second, let's just have a look at this JSON. So inside this JSON message, we have the operating system disk, but we also should be having somewhere information about the encryption side of the house. Why don't I see this? Sorry, why don't I see this? Let's just grab these values here. OS disk key. Let's just have a look here. I actually have a problem to look into the key because I myself, even though I created this key vault, I am not yet authorized on the key vault. So let's just go to the access control here and do a role assignment for myself so I can let's make myself a crypto officer. Because otherwise I cannot retrieve the correct name for the encryption key. So let's resource the, so this is the, no. Let's grab the virtual machine description and let's grab these ones. What do we have here? Yeah, and now we can basically also ask for the disk encryption sets information, I hope. Yes, exactly. Let me just control minus. Yeah, oops. Let's just zoom out a little bit and echo this information again. So here, the operating system disk we're interested in is this disk. The disk encryption set is the DEK thing, and the key vault, or let me just, yeah, the key vault key is the DEK 1. Yeah, zoom in, zoom out. Sorry for all that mess, but let's just paste it here so then we can see it slightly better. So here's our OS disk. So now we can see. So K1 in this version is used by this disk encryption set to get access to this one. So this information we fetched as customer. So now let's sign in to the Azure AAD tenant of the ISV. Actually, do I need to even sign in interactively, or what am I doing here? Okay, so now I am going to, I should actually have done this using the service principal, but it doesn't matter. So let's now create a disk encryption set on the ISV side of the house. So now we want to create this disk encryption set over here. So the encryption type, we want to use REST, encryption at rest with platform and customer managed keys. And now we can see the tricky part. So this time we create a disk encryption set, but we explicitly name the user assigned managed identity we want to use. So let's roll the funky music and do this one as well. So here we can see we want to run in this region. We want to have a user assigned identity, which is the one for our tenant. And the key is pointing to a key vault on the customer side. And we want to use this service principal at the customer side to gain access to it. And just for readability purposes, I added a couple of tags so we know like for which customer environment this particular disk encryption set will be for. So now let's just put the information about the disk encryption set into Azure with the JSON body here, and let's wait for Azure to create that resource. And no error message, no nothing. That's great. That's the no. Is this the response? Let's just have a look at what happened in the ISV environment. So let's go into our resource group. Here we wanna soon see the disk encryption set show up. Let's just refresh this again. There we go. So here we have I named also it with the subscription name and the region of the customer, so we know what this belongs to. So if I go into the disk encryption set, here I have a couple of tags which help me to find out which customer this was created for. It lives in our subscription, but it is for a key vault in the customer subscription. The key, it points to a key vault on the customer side. And yes, that is exactly like, so what we now have is this one is now able to use this managed identity with a service principal and the multi-tenant app to tap into this key. So now we have access to the key, at least for the purpose of decrypting disks. The next step to execute is, actually, let's check the provisioning state. We can also, via REST, of course, check the provisioning state of our disk encryption set. It succeeded, right? So now let's try the whole snapshotting operation. So we use our service principal, password and ID to sign in to the customer tenant. Just for the sake of the experiment, let's have a look at the properties. This is the customer tenant here who gave us this token, right, for our service principal. Now again, like in the previous demo, timestamp, snapshot name. Let's define a certain snapshot. We want to use the Active Directory authentication to tap into it from our operating system disk. So this is the body which we'll be putting in for the disk of the encrypted VM. The snapshot resource ID is this one. This is now the actual put operation of the snapshot. So here we are creating the snapshot. And the response came back that the snapshot is now underway. Let's just, oops. Having a look now my cursor jumped around. Sorry for that. So let's briefly have a look at the snapshot information, which is basically what already came back. So now the snapshot exists. So this one is turquoise as well. You might remember from the previous picture, now comes a little nifty trick where we need the identities from both service principals, like from this one and from that one, to actually trigger the materialization of a disk. We need to prove we are authorized to read the snapshot and we are authorized to write the disk. This is why we need 2 access tokens. So let's grab these 2 access tokens, one for the customer side and one for the publisher, for the ISV side. Let's briefly have a look into these access tokens. So you can see the app ID is the very same, but the issuers are different issuers, and the audience is in both cases the management API. So we are now ready to create our disk. So the disk ID is at the ISV side in our demo resource group, the customer, whatever naming scheme we come up here. Again, now we need to make sure the disk is manifested or created in the availability zone in which we want to mount it. And we also refer to the disk encryption set necessary to decrypt the contents of the disk. So let's just have a look at the JSON body which we will be pasting. So we want to copy from the snapshot at the customer side. We want to use a disk encryption set from the publisher side. So which basically points to, yeah, it's convoluted, but that's the way it is, right? So let's trigger the disk creation, keeping fingers crossed. So now we basically put the disk into Azure. Let's have a look here. So this is now in provisioning state updating. And let's just figure out what Azure can tell us about the disk. So here we see the source of the disk is the customer subscription, customer resource group, snapshot at the customer side. The ID of the disk is our ISV thing, ISV resource group, and an encrypted VM. And the encryption type is encryption with platform and customer keys. And the disk encryption set is coming from the publisher side, right? In availability zone 1, and of course, it is not attached to anything. So cool. Let's have a look. And there you go. So here is the disk, which came over from the customer side. And when we look into the encryption, it basically points to this disk encryption set. So now we are actually running, able already to start a virtual machine. So let's just do that. So virtual machine, but well, actually I pause the video and we do this later. So next plan is to create, I actually need to figure out where was I. So let's create a virtual machine in the ISV subscription to attach the encrypted disk. So this would of course usually be a system which is fully automated. Scanner would be the VM. We now must pick the same region and availability zone, that's important, where our disk lives. So let's pick a generation 1 virtual machine again. Secure shell. So let's take the key. And in the disk section, it actually doesn't really matter what's going on with the operating system disk, but with the data disk, we want to attach an existing disk. And we pick the encrypted one. and it should know just be, well, no, wait. Encryption type. Okay, so here we actually select which encryption set to use, and go further down the road. Let's just create this virtual machine finally. And I just pause the video for a minute until the provisioning process is done. And the virtual machine is up and running, so we can go to the resource. This is now our ISV side virtual machine, so let's SSH into the box. Let's become an administrator and make a data drive folder and LSF. Let's look at the disks. So the disk which we want to mount is this one here. So mount dev SDC1 on data drive. Let's have a look there. So this is, so now we need to go to our home folder and chgeuer, because this is where basically the file which we created on the guest, on the customer VM is basically located. And so this demo shows you how you can, let's just go to have a look at the resource group. So in our ISV side resource group, we are having the virtual machine, which mounts an encrypted customer disk which is basically using this disk encryption set and the user assigned managed identity to gain access to the other side. So the VM uses a disk, which uses a disk encryption set, which uses a managed identity, which uses a service principal on the other side to get read access to the key and key vault. And that's pretty much this part of the demo. I hope there wasn't a big break in the last 5 minutes because I came back from a short